Hi, this is Mr. Riley's Maths videos, and today we're looking at probability and set theory, and this comes up both at junior cert level and at leaving cert level. So we're going to look and see how do the two topics cross over, and we'll just do a quick review of probability and or a quick review of sets. And really, when we're talking about set theory, we're generally talking about Venn diagrams. Okay, so if you remember Venn diagrams, they were a way of representing sets. So here we've got two sets. We've got set A, which has the elements 1, 2, 3, 4, 5, 6. We have set B, which has the elements 4, 5, 6, 7, 8. And U is the universal set, and that's got all the elements that we need for this particular question. So it's got the numbers 1 to 10. So a Venn diagram for this will consist of a box, which will be our universal set. Okay, and that's got those 10 figures. And then we'll have set A and set B. I'm assuming there's some in both. Yep, there's some elements that are in both. And then, so this is A and this is B. Now, if you remember, when we draw a Venn diagram, we start in the center and work outwards. So we're looking here for the things that are in A and B at the same time. So 4, 5, and 6 are in set A, and 4, 5, and 6 are in set B. So we do 4, 5, and 6. And if you notice, each element, so each item in a set is called an element, and each element in the Venn diagram has a little dot beside it to show that it's an element, and we'll see why that's important in a minute. What else is in A? Well, 1, 2, and 3 are also in A, but they're not in set B, so they go in the part of the A circle that doesn't overlap with B. And what goes in the B circle, we have 7 and 8 left over, so they go in that part of the circle. And then what's not included so far from U is we've got 1, 2, 3, 4, 5, 6, 7, 8, so 9 and 10 must go outside the circles to show that they're in the universal set, but they're not in set A or B. And if you remember, then we have certain symbols, so we'd have something like the cardinal number of A, written like that, means the number of elements in A, which is 1, 2, 3, 4, 5. There's 6 in that. Okay. The cardinal number of B is the number of elements in B, 1, 2, 3, 4, 5. Okay. We have things like A intersection B would be the elements that are in A and B in this overlap. So that would be 4, 5, 6. And let's see, A union B is all the elements from both sets. So 1, 2, 3, 4, 5, 6, 7, 8. So the two sets united. A less B are the elements that are in A but not in B. 1, 2, 3. And B less A are the elements that are in B but not in A. And then we also come on to do complement. A complement is the elements that are not in A. So that would be 7, 8, 9, 10. So hopefully that's a good review of some of the terms that we come across with set theory. So this, I'll just say this is cardinal number, and this is intersection, this is union, this is A less B is how we say that, and we call this A complement. Okay, so when it comes to probability, they would say something like this. What's the probability that if I select a number at random from set A, if I select a number at random from set A, what's the probability that it's an even number? So the probability of selecting an even number from set A, well, that's 2 and 4 and 6. So the probability is 3. If it's from set A, then it's out of 6. So it's a probability, if the number is selected from set A, the probability that it's even is 3 out of 6 or 1 out of 2. But from the whole universal set, the probability of an even number would be 2, 4, 6, 8, 10, 5 out of the total number of numbers, which is 10. So again, it would be a half. But if you notice, it's a half for a different reason. So with set theory, we have to be careful of what numbers are we looking at for the total possible outcomes. So here it was 6 because we were just looking at set A. Here it was 10 because we were looking at the whole universal set. And then what about the favorable outcomes? How many favorable outcomes are there in that set? Well, here there was 3 and here there was 5. Okay, so that's the idea of just how we draw the Venn diagrams and how the question might be phrased. Now, if you notice that this Venn diagram here, there's no little dots, and that's because 12 is not an element there. 12 represents 12 elements, 8 elements, 15 elements. So in this G circle, which is the number of people who play golf, I've got 12 people here and 8 people here. So altogether in the G circle, I've got 20 people. So cardinal number of G would be 20. The cardinal number of T would be 8, and 15 would be 23. And as you can see, the cardinal number of U is 40. Okay, so here we have this group of 40 people. The ones in this circle play golf, the ones in this circle play tennis. So you might get a set of questions like this, and let's just work through them and talk about any issues. In fact, why don't you do this? Why don't you pause the video, write down what you think the probabilities are, and then start the video again. Okay, so hopefully you've had a go. The probability that if we were to pick somebody at random from these 40 people that they play golf, there are 12 and 8, 20 people who play golf out of 40 people, so that's a half. The probability would be a half. The probability that they play golf but not tennis is only these 12 people. These 8 people play tennis. They play golf and they play tennis. So this group here is going to be 12 out of 40, which should be what? 4 goes into both 3/10. Because these people play golf but not tennis. The probability that they play golf and tennis would be 8 people, because that's the overlap. The people who play golf and tennis are the ones in the overlap, which would be 8 out of 40, which should be 1 out of 5. The probability they play either game or both games is basically anybody who plays a game. So that's 12 and 8 is 20 and 15 is 35 out of 40, or 7 out of 8. And they play neither game. They do not play either game. It's going to be these 5 people out of 40, which is 1 out of 8. Now if you notice, the probability of those that play one of the games or both of the games, and the probability of those that play neither game, so who do not play either, those two probabilities add up together to give 1, because they're opposites of each other. You either play a game or you don't play a game. Okay, so those are the two possible outcomes when it comes to that. So that's why the probabilities add up to 1. Now, here's one more question, a bit harder because we've got three different things here. These are the probability. These are the people who shop in one of these 3 shops: Penny, Zara, and Bershka. And there's 50 people that were asked, and P stands for Penny, Z for Zara, and B for Bershka. Okay, so why don't you again pause the video and see whether you can answer these. The probability that if someone was to be selected at random, that they would be, for instance, someone who shops in pennies. Okay, so pause the video. We'll go through it in a moment. Okay, so hopefully you've had a go. Here's our 50 people represented in this box. We have 3 circles. This one represents pennies, this one represents Zara, and this one represents Bershka. Now with 3 sets and 3 different things, there's quite a few different combinations we could have. So we have to read the question carefully to see what it means. The probability that if we were to pick someone at random from this group that they shop in pennies is saying how many people are in the penny circle. How many people are in the penny set? There's no other restrictions other than that they shop in pennies. So that's 10 and 6 is 16 and 4 is 20 and 10 is 30 people. So 30 people out of 50 people shop in pennies. So that's 3/5. Okay. How many people shop in Bershka and Zara? So Bershka and Zara would be these people here. They shop in Zara, they're in the Zara circle. They shop in Bershka, they're in the Bershka circle. So these people here shop in Bershka and Zara. So 4 and 3, which would be 7 out of 50, which doesn't reduce. What about if they shop in pennies or Zara? So pennies is all this circle, which we found out was 30. Now, the people that shop in Zara are in this circle, but we've already counted the 6 and the 4. So we'll just have the 30 of the pennies plus the 9 and the 3, which would be 30 plus 12, which should be 42 out of 50, or 21 out of 25. Shop in all three shops is everybody in all three circles. And if you notice there's nobody outside the circles, let's just double check. 10 and 6 is 16 and 9 is 25, 28, 32, 42, 50. Yes. Shop at all three shops. So actually all three shops is actually this one here in the center, isn't it? It's people who shop in pennies, they're in the penny circle. People who shop in Zara, they're in the Zara circle. And people who shop in Bershka, they're in the Bershka circle. So that's those four people there. I nearly misread that, didn't I? So that'll be 2 out of 25, 4 out of 50. Shop in Zara and Bershka, but not in pennies. So they shop in Zara, they shop in Bershka, but they don't shop in pennies. So these people are the ones that shop in Zara and Bershka, but these ones shop in pennies, so we're not interested in those. So it's just these three people that we're interested in, 3 out of 50. And shop in only one of the shops. They shop in only one of the shops. That's these 10 people who only shop in pennies, these 9 people who only shop in Zara, and these 8 people who only shop in Bershka. So it's 10 and 9 is 19 and 8 is 27 out of 50. Okay, I hope that makes some sense. Bye.